Hello Legacy Sabers, Marsh here. So this is the second video on the semester 1 review. We're going to start on question 17 on this video. So we're going to solve some systems. So 2x plus 2y equals 6 and x plus 3y equals 5. There we go. So you can do any algebraic method. I'm going to do for this one, I'm going to do substitution. So I'm going to take this bottom equation and solve it for a variable, which would be negative 3y plus 5. And then I want to substitute this for x into the top equation. So 2 negative 3y plus 5 plus 2y is equal to 6. Okay. Distribute that 2 in, negative 6y plus 10 plus 2y equals 6, because now I'm just down to a variable of y. Negative 4y plus 10. I'm going to start to solve here for my y. Oop, lost that. Minus 10, that would be negative 4. So y equals 1. Okay. Now, to find x, what I'm going to do is I'm going to plug that 1 into this equation here that's solved for x and see what I get. So negative 3 times 1 plus 5. It's negative 3 plus 5. So x is 2. So my answer is 2, 1. Number 18, I'm going to do elimination, which required me to multiply one or both of the equations by a number to get a variable to cancel out. So the first thing I notice is that I have a negative x and a positive 2x. So I'm going to multiply the top guy by 2. Negative 2x plus 4y equals 2. Okay. Those cancel off. 3y plus 4y is y. 0 plus 2 is 2. So I have y is 2. So I'm going to take that, plug it into one of the two equations. So negative x plus 4 equals 1. So negative x minus 3. So x is 3 as well. So 3, 2 would be the solution to that system. Moving on to matrices. Dun, dun, dun. So, first thing I want to do, this is just adding and subtracting matrices, so I'm going to distribute a 2 into everybody. So I got 2, 14, negative 2 and 8, minus 6, 0, 15, and negative 6. Okay, just distributed the 3, I didn't distribute the negative. So now I got to go 2 minus 6, that is negative 4. 14 minus 0 is 14. Negative 2 minus 15, that's negative 17. And 8 minus a negative 6 is 14 as well. So that would be my correct answer for that one. Multiplying matrices, you can do it on the calculator, but this one I think I'm going to do via multiplying rows by columns. So multiply this row by this column to get my first answer. So 3 times 1 is 3. Negative 1 times a 4 is negative 4. So now I'm going to go this row times this column. So 3 times 3 is 9. Negative 1 times a negative 2 is a positive 2. Now I got to go this row times the first column. So 5 times 1 is 5. Plus 0, and then this row times that column, so 15 plus 0. So I get an answer of negative 1, 11, 5, and 15. And then this one, notice how this is different. Okay, this is the determinant. You gotta find the determinant of this. Mr. Calculator can accomplish this. However, remember it was just this guy times that guy minus this guy times that guy. Quicker that way than using the calculator. Unless we did 3 by 3 determinants, which definitely calculator was faster there. I'm going to add, so it looks like my answer will be 36 for that particular problem. So moving on to absolute value functions. Bum, bum, bum. Okay, so first thing we have to remember, how does this transform? Well, we have a vertical stretch of 4, left 3, and down 6. Okay, now I need to remember, what does that mean for my translated? Well, I'm going to make a little normal table here. So -2, -1, 0, 1, 2, make it my parent. Well, parent of absolute value would just be absolute value of the x. So that means 2, 1, 0, 1, 2 will be in my table. And I'm going to transform that. So I'm going to go left 3 on all my x's. I'm going to multiply by my vertical stretch, which is 4. And then I'm going to go down 6. So let's write my new table out here. Tablet's going a little crazy here. It's -5, -4, -3, -2, -1. So I just subtracted 3 from all my x's. These ones, 2 times 4 is 8, minus 6 is 2. 1 times 4 is 4, minus 6 is -2. 0 times 4 is 0, minus 6 is -6. And then since this does mirror, I know that those are going to be it. So let's go ahead and graph that. 1, 2, 3, 4, 5. 1, 2, -4, -2, and -3, -6. 1, 2, 3, 4, 5, 6. And these guys are going to go right here. Like that. Pretty answer. There we go. My vertex then is -3, -6. That's the dot in the middle. Intercepts, oh, probably guessed them here because they didn't come out nice. Probably -1.50 and 1, 2, 3, 4, 5, 4.50. Looks like the answers. I could set this equal to 0 and solve. I just decided not to. I believe those are the actual ones. This would be a neither graph. Remember, it doesn't fold over the y-axis, doesn't fold the first quadrant, the third quadrant don't match, so that's neither. Definitely continuous. Domain, that would be -infinity to infinity. Range, however, notice he does get to an end, so he stops at -6. I'm including it because it's bracket. To infinity. Okay. Boundedness, it is bounded below the graph. Concavity, it is up like a cup, right? It's pointing upwards, opens up. Increasing interval, we are increasing from -3 to infinity, right? So starting here, going up. Decreasing -infinity to -3. Remember, these are always your x values. Extrema, our absolute minimum, is going to be the bottom point. So y equals -6 at x equals -3. The local min is the same as that one. Absolute maximum is infinity, and the local max does not exist. Okay, got 2 more problems to go through. So solving this equation, well, first thing we want to do is get the absolute value alone. So I'm going to add 2 to both sides. We're going to have 1/2, 2x plus 3 equals 9. Got to get rid of that half, so I'm going to multiply both sides by 2. So that's 2x plus 3 equals 18. Now I need to split this, because remember, absolute value equations need to be split. So I'm going to split it into 2x plus 3 equals 18. and 2x plus 3, or the negative value of that, because there's two sides to the absolute value, so you got to worry about two equations. So now I'm going to solve this guy. So I'm going to get x equals 15 halves, it looks like, 7.5. Distribute my 2 in. I got to add the 3, so that's 21. Whoa. X equals negative 21 over 2 for my answer. And the final one, piecewise functions. So remember, guys, you're going to graph and erase. So I'm going to graph x minus 4. I'm going to graph that line. 1, 2, 3, 4. And I'm going to go up 1, over 1 a whole bunch of times. So I'm going to do that for the entire graph. I'm going to put a bunch of dots here. Might take me a minute. Okay. And I'm only going to keep this line as long as x is less than or equal to 1. So I'm going to go to 1 and decide which side of the graph am I keeping. Am I keeping this side of my graph or this side? Well, I'm going to be on the less than 1, so that means I got to keep this side of my graph, right? So that means I got to go up here. I'm going to take my eraser, do some cleaning of all my dots. There we go. Undo my eraser. And get my pen back. There we go. And then it is at equal to, so I'm going to put a nice big closed dot there. Now I got to graph 3x plus 2, so I'm going to go up to 2, go up 3 over 1, do my slope here. Well, this needs to be greater than 1, right? So I know I have to start at 1, and I'm going to go to the right with my graph. So I'm going to do some erasing here on that dot. There we go. Then I'm going to put a big giant open circle there because it is greater than, not equal to. And that's the end of this video. So continue on to the third video to watch for some more of the review packet for semester 1. But until then, see you later, Sabers.